Welcome to Prospective Doctors MCAT Podcast, brought to you by Med School Coach. Each week, Sam breaks down the highest yield MCAT topics so you can score as high as possible on test day.
Hello and welcome to Prospective Doctors MCAT Basics with your host, Sam Smith. The goal of this podcast is to cover the highest yield topics on the MCAT and provide you with some sort of insight into the questions that the MCAT really likes to ask. This podcast is going to cover intelligence. First thing I'm going to do is go through a few different theories of intelligence. I'll talk about the G-factor theory, the Triarchic theory of intelligence. I'll go through the theory of multiple intelligences, and then a few others. And then I'll go through the hereditary factors that underlie intelligence. And then lastly, I'll get a bit into how we measure intelligence. This material is mainly going to show up on the Psych-Soc section of the MCAT. And with that said, I hope you find this podcast helpful and that you're staying safe. What I want to do first in this podcast is just define intelligence. It kind of seems a little bit like an abstract concept, so I just want to put it into words what it is. So psychologist Roger Sternberg, which you'll hear more about him in a second, defines intelligence as one's ability to learn from experience and to adapt to, shape, and select environments. David Perkins, who's a research scientist and interesting guy, received his PhD in mathematics and artificial intelligence from MIT, defined it a little bit differently. He said that intelligence is a combination of the ability to learn, the ability to pose problems, and the ability to solve problems. So I think that's an interesting definition. I like that one maybe a little bit better. But as I go throughout this podcast, I'm going to talk about a bunch of different theories, a bunch of different factors that people believe underlie intelligence. And hopefully all of that together, you're able to kind of see the definition of intelligence a bit more clearly. All right, so with that said, let's get into some of these different theories of intelligence. And the first theory here that I want to talk about isn't really a theory of intelligence, it's more of a theory of motivation. And so I thought I'd bring it up first and just kind of give that caveat right away. Not really a theory of intelligence, more of a motivation, but it is the entity versus incremental theory. And it essentially says that a person holds one of two views on their own intelligence, or I guess of others' intelligences as well. They either hold the entity point of view or the incremental point of view. The entity point of view says that intelligence is fixed and, each person is born with some allotted share of intelligence and that they can't really do much throughout their life to actually increase that intelligence. In contrast, the incremental point of view says that your intelligence can be increased through your own effort. In other words, you can increase your intelligence over time depending upon your actions, depending upon, your learning, whatever it may be. So just to give you an example, pretend that I have the entity view of my own intelligence. Well, then I would believe that I was born with a set amount of intelligence and there's nothing I can do to increase that in my life. Now let's erase that and now pretend that I actually hold the incremental theory about my own intelligence. Then I would believe that I was not given just a set amount of intelligence at birth. Instead, I might believe that reading or listening to podcasts or whatever it may be is actually increasing my intelligence, so I'm kind of motivated to do more of that. So you can kind of see that this isn't necessarily a theory that tries to explain what intelligence is. It more asks the nature versus nurture question. Is intelligence something you're born with or is it something you develop over your lifetime? And in terms of this being more of a motivational theory, psychologists like Stanford's Carol Dweck argue that people that hold this entity theory point of view tend to have more of a fixed mindset, whereas people that hold the incremental theory point of view tend to have more of a growth mindset. And you can see pretty clearly why that is. And Dweck goes on to argue that the incremental viewpoint is very important for children to hold, and it's very essential in their learning and their healthy self-conceptualization, which makes quite a bit of sense to me. And a bit later in the podcast, I'll get into this nature versus nurture argument for intelligence. And it actually turns out that it's a little bit of both. But I think the takeaway here is just to understand what entity theory is, what incremental theory is, and how having either of these viewpoints can affect your motivation. All right, so let's get into some real theories of motivation now. And before I really jump into these, there's something you should know. And this is important. I don't think this is something that would come up on the MCAT, but this is just something important for sorting out these theories in your mind. So there are different types of theories here. Some of these are based on psychometrics, which is just a metric for how psycho you are. Just kidding. So psychometric theories derive from studying individual differences in test performance on cognitive tests. So essentially, these theories look at cognitive tests and then they are derived based upon those tests. There are also systems-based theories, and these attempt to characterize the system of structures and mechanisms of the mind that comprise intelligence, and I'll kind of categorize these theories as I bring them up. And then lastly, there's biological-based theories that try to use biology to explain intelligence. So as I said, as I introduce these theories, I'm going to tell you which category they fall into. But I do think it's actually really important to make the distinction, because when we're talking about biological theories and, maybe different structures in the brain being bigger and that correlating to intelligence, that's of a whole different kind than when we're talking about like the G factor and all these different intelligences that add together into the G factor of that overall intelligence. So they're two completely different theories, and one's based on like psychology, the other is based on biology, and so they explain intelligence in just totally different ways, and you'll definitely see what I mean when I go through these. All right, so the first theory I want to go through here, and probably also the most well-known, is the general intelligence theory, or the G-factor theory. And this is a psychometric theory. And this theory was developed by psychologist Charles Spearman. And it comes from Spearman's observation that people who perform well on one type of cognitive test are likely to do well on other types of cognitive tests. So for example, he would notice that someone who did well on, say, a mathematics test would also tend to do well on spatial visualization tests, verbal tests, memory tests, and so on. And so because of this, Spearman thought there must be some underlying single factor that is responsible for a person's intelligence. And he called this underlying factor the G factor. So Spearman's general intelligence theory just says that there's this single underlying factor that determines someone's individual intelligence, and that's the G factor. And Spearman actually kind of elaborated on this general theory of intelligence into what he called the two-factor theory of intelligence. And again, this two-factor theory of intelligence is still in the psychometric category of these theories. And this theory says that there are two components to intelligence. It says that there is the G factor and the S factor. I already talked about the G factor, that's just the general intelligence factor. The S factor is the specific ability factor. And it accounts for the fact that we don't perform exactly the same on all these different intelligence tests. As I said earlier, Spearman came up with this G factor theory because he recognized that your score in one intelligence test tended to predict your score in the others. But he also noticed then that they didn't perfectly correlate together. So say, for example, you take 4 different cognitive tests to measure your intelligence. You take a math test, a common sense test, a cleverness test, and a spatial awareness test. And let's just say they're scored 1 through 10. And of course, I'm just making this up. But let's say that you score an 8 on the math test, a 6 on the common sense test, an 8 on the cleverness test, and a 9 on the spatial awareness test. So what Spearman would say would be, okay, well, you scored pretty well on all these tests, and that's because you have a pretty high G factor. But the scores of these individual cognitive tests are all a little bit different, and that's because they are all specific abilities and all fall into the category of S factors. Another way to look at this, and I kind of like this way, it's from Wikipedia, is to imagine each of these specific intelligences, which again, let's just make up math, common sense, cleverness, spatial awareness. Imagine these as 4 circles, and they're all overlapping. And so it's like a 4-way Venn diagram. And so the individual circles themselves are considered the S factors, right? These are specific intelligences. And where they all overlap is what's known as the G factor, right? That's the underlying factor that determines a person's intelligence. So just to summarize these two theories, Spearman is known for 2 different things that I talked about in this podcast. The first being this G factor, or this general intelligence factor. He believes that there is a single underlying factor that you can boil down one's intelligence to. And then he's also known for the two-factor theory that incorporates his idea of the G factor, but also accounts for the fact that individuals score differently across different specific intelligence measures. So he introduced the S factor to explain that. And so overall, his two-factor theory just says that there's a G factor and an S factor to intelligence. And the last thing I'll say is that if you're looking for another podcast to listen to right now, maybe you're bored, got a lot of time on your hands, you want to learn more about this G factor, Radiolab did a really good series of podcasts on the G factor. Maybe it'll help you learn it a little bit better. I think it was very interesting, so I totally recommend it if you're interested. All right, so the next theory I want to talk about is called the Multiple Intelligences Theory, and this is a systems-based theory. And it was developed by Howard Gardner, who was a Harvard psychologist. And as you'll see, this is kind of a theme. It seems like a lot of the psychologists that come up with these theories are all either like Harvard, Stanford, some kind of Ivy League. They're all went to these top schools. And I don't know why that is, but I guess probably because they're the best psychologists, or I like to think. But anyways, his theory of multiple intelligences says that we have 8 distinct intelligences. And he described these 8 intelligences as the following. You have linguistic intelligence, or how word smart are you? You have logical mathematical intelligence of how good at number reasoning or how good at math are you? You have spatial intelligence, which essentially is how picture smart are you, how visually smart are you? And then you have a bodily kinesthetic intelligence, which is like how body smart are you or how good are you at moving in 3-dimensional space. And then you have musical intelligence, which is pretty self-explanatory. Then you have interpersonal intelligence, which is how people smart you are. Then you have intrapersonal intelligence, which is how self-smart you are. And then you have naturalist intelligence, which essentially asks how nature smart are you? And critics of this theory tend to say that these are more of talents than intelligences. They also tend to say that there's not a lot of empirical evidence to support this theory. Spearman would probably say, what you described is true. There's all these different intelligences, but I can explain that using my S factor, and there's still this underlying G factor. G factor. So Gardner's theory of multiple intelligences just says that there's 8 distinct intelligences. The next theory I want to talk about is called the Triarchic Theory of Intelligence. And this was developed by a Cornell, of course, psychologist named Robert Sternberg. And Sternberg agreed with Gardner. He believed that there were multiple categories of intelligence. However, when Gardner said that there are 8 different types of intelligences, Sternberg disagreed and said, quote, 3 is the magic number. And from this, he developed his Triarchic Theory of Intelligence. And his theory says that intelligence breaks into 3 independent parts. It breaks into the practical part, the distinct part, and the analytical part. So the first of the 3, practical intelligence, is described as the ability to get along in different contexts. And this has to do with successfully interacting with your environment and others around you. And I kind of like to think about it as common sense. The second component to intelligence in this theory is creative intelligence, and this describes the ability to develop new ideas. And that's pretty easy to understand. I like to just think about that as creativity. And then the third component of intelligence in this theory is analytical intelligence, and it just describes the ability of someone to evaluate information and solve problems. And I just simply like to think about this as problem solving. And critics would say, again, that there's not a lot of empirical evidence for this theory. Spearman would say these are just 3 S factors of intelligence, and there's still this G factor that underlies these 3 categories. The Khan Academy video says that Spearman might say that these 3 intelligences are just 3 different sides to the same coin, which obviously, all coins are 3-sided, so this makes a lot of sense. But I actually kind of like this theory. It seems to me like these are 3 distinct categories of intelligence. I know some people who are really, really book smart, but don't have a lot of common sense. But on the other hand, a lot of people that have a lot of creative ability also seem to have a lot of analytical ability that I've recognized. So maybe those 2 don't go together. But, just anecdotally, I know some really, really smart people getting their PhD in physics right now who just have 0 common sense. The next theory that I want to talk about is called the Cattell-Horn-Carroll, or CHC theory. And this one is based on psychometrics. So this is named after 3 psychologists, the first being Cattell, who spent some time at Harvard, Horn, who actually didn't spend time at any Ivies or Stanford or any of the like. And then there is Carroll, who spent time at Harvard, Chicago, among other schools. And so this theory is a synthesis of 2 theories. So I'm going to go through these 2 theories that it's a synthesis of, and then at the end kind of wrap it up so that you understand this overall CHC theory. So let's start with the first theory that underlies this CHC theory, and that is called Cattell and Horn's Gfgc theory. And this is another 2-factor theory, and it said that intelligence is broken down into 2 different factors. The first being fluid intelligence, the second being crystallized intelligence. Fluid intelligence is described to be quantitative reasoning, processing ability to adapt to new environments, and then also novel problem solving. And Cattell and Horn believed that fluid intelligence reached its peak during adolescence. And I kind of like to think about this as like, how quick are you at thinking of things? Crystallized intelligence, on the other hand, is the accumulation of knowledge over time. And this is gained through education and also life experiences. And so crystallized intelligence reaches its peak typically at old age before your memory starts to get impaired. More simply put, fluid intelligence is problem solving, and crystallized intelligence is knowledge that is acquired or learned. And I will mention that these intelligences actually overlap because fluid intelligence is the determining factor in the speed with which crystallized knowledge is accumulated. Hopefully that makes sense, right? The higher fluid intelligence you have, the more problem solving, kind of the more quicker wit you have, and therefore you're able to pick up information faster and retain that faster, so your crystallized intelligence accumulates faster. The second theory that underlies this Chc theory is called Carroll's three-stratum hierarchy. And this is a three-factor theory of intelligence that says that there are three categories of intelligence. There are narrow abilities, which are stratum 1. There's broad abilities, which are stratum 2. And there's general abilities that are stratum 3. And so there's a ton of things that fall into this narrow ability stratum. There's like 70 plus in just the paper that I was looking at, so there's a shit ton. And then there's fewer of these broad abilities, and then there is a single general ability, and of course that's the G factor. And so you can kind of imagine it as like an upside down pyramid essentially, right? At the top, you have all of these narrow abilities that people can, have different levels of. And then between there, you can have a bunch of different broad abilities, but not as many as the narrow abilities. And then at the very point of that upside down pyramid, and somehow it's balancing, I don't know what's holding it, but right at the point, there's that general ability, which is that G factor. And so where the theory from before comes in, this fluid intelligence and crystallized intelligence theory, where that comes in is that those two fall under the category of broad abilities. So those go into the broad abilities category, which is stratum 2 in this three-stratum hierarchy theory. And together, they make up what's called the Cattell-Horn-Carroll theory, or the Chc theory. So just to quickly summarize, the Chc theory is a combination of two different theories. The first being this fluid intelligence versus crystallized intelligence theory. And I do think it's important to understand the difference between those two and be able to apply that. But it combines that with this three-stratum hierarchy, and fluid intelligence and crystallized intelligence fall under the broad ability stratum in the overall theory. So really what they did is they took Carroll's three-stratum hierarchy theory, and they just plugged in the crystallized and fluid intelligence theory right in there. They combined them and called it the Chc theory. All right, so the last theory I want to talk about here, and really it's a group of theories, are biological theories of intelligence. And again, these are just different in kind than a lot of the other theories that I've talked about, because those are trying to explain intelligence from more of a psychological lens. These are trying to explain intelligence through a biological lens. And there's a bunch of different biological theories of intelligence out there, and I'll just give you a few for example. So Hendrickson and Hendrickson in 1982 argued that higher intelligence is related to a smaller probability of neural transmission errors in the brain. In other words, they say that the lower the number of errors you have while information is being transmitted around through neurons, the smarter you are. In a similar theory put out by Richard Heyer of UC Irvine, he suggests that intelligence is somehow related to how efficiently information travels throughout a particular brain. So the more efficiently a message is sent and travels through all the neurons in the brain, the smarter you are. And then there's others that have postulated that there's a relationship between brain size and intelligence. You've probably heard people say, you're a brainiac or you have a big brain or something like that. And they would essentially be referencing this theory. And so in conclusion, biological theories of intelligence are ones that directly link differences in biology to differences in intelligence.
Thanks for checking out the Prospective Doctor MCAT Basics podcast. Sam's doing a killer job taking you through the most important MCAT topics, but what if you need a little extra help? How does a 5, 10, or even 15-point increase in your score sound? Imagine how your chances at admission could increase. Med School Coach's MCAT tutoring can get you there. With the most rigorous selection process of any tutoring company, we see amazing results. We deconstruct each student, find a plan that is going to work, and help execute it. That's why our students add an average 12 points to their score. Completely physician-run and operated, and focusing on nothing but medicine. It's no wonder over 10,000 past students have trusted Med School Coach to get them through the MCAT and into medical school. Check out medschoolcoach.com today and mention code PODCAST for 5% off.
In this next segment of the podcast, I want to talk a bit about the hereditary factors of intelligence. And I want to get more into this nature versus nurture argument. How much of our intelligence comes from our parents and how much of it is acquired during our lifetime or due to our surroundings when we're children, teenagers, etc. And so according to a 2012 paper by Sternberg, there is no single gene that has been identified that is critical to a person's intelligence. In other words, there's no smart gene. And this kind of goes along with a lot of other personal characteristics like hair color, skin color, height. They all seem to be polygenic, meaning they're influenced by multiple genes. And how many genes, you ask? Well, there was a 2017 paper that was published in Nature Genetics by Sneakers et al. That found 52 genes that were linked to intelligence. And this was a meta-analysis, which is essentially an analysis of a bunch of data from a bunch of different papers, and it included approximately 80,000 people. So a lot of people, a lot of intelligence data, and they were able to find 52 genes. And of course, keep in mind that we're talking about correlations here. So we see that these genes correlate well with intelligence, but correlation does not equal causation. So we can't say that these genes are what's causing someone to be highly intelligent. You can't get that kind of relationship out of this type of data. Another type of study that can look at the inheritance of some characteristic, in this case intelligence, is a twin study. And so twin studies look at heritability, which is defined by the NIH as a measure of how well differences in people's genes account for differences in their traits. And so in terms of intelligence, what we'd be asking is how well do the differences in people's genes account for the differences in their intelligence? And through these studies, we're able to actually tease out how much of some characteristic is due to nature and how much is due to nurture. So I'll go through how these twin studies work and you'll get a better idea of how they figure this out. So in a twin study, what they do is they look at first identical twins, which are 100% DNA matches, which I'm an identical twin. So I have a twin brother who has 100% the same DNA as I do, minus, a few somatic mutations here and there. And they also take fraternal twins, which share the same amount of DNA as just a sibling would. So you imagine you have these two groups, right? You have identical twins and fraternal twins. And what they're able to do is in the pool of identical twins that they're looking at, they're able to see that some of these were separated at birth. Maybe they were given up for adoption, given to different households. And so those individuals would share the same DNA, but they'd be in different environments. And then they can also take identical twins that were not separated at birth, and they are DNA matches, and they share the same environment. Now, in the fraternal twin pool, you have the same thing, right? You have fraternal twins that have the same environment, and you have fraternal twins that were separated at birth and therefore have different environments. So now you have four different conditions here, right? You have identical twins that were separated at birth, so they share 100% DNA, different environment. You have identical twins that were not separated at birth, which share 100% DNA, 100% environment, or close to 100%. Then you have fraternal twins that were separated at birth, which have different DNA, different environment. Then you have fraternal twins that were not separated at birth that have different DNA, but same environment. Now from there, what you do is you look at the twin pairs within each of these four conditions. And what you're looking at is you're looking at the difference in IQ or difference in intelligence between the twin pairs. So for instance, me and my twin brother would fall into the category of identical twins and also raised in the same household. So we'd have the same environment, we'd be DNA matches, so we'd fall in that one category out of four. And then what the scientists would do is they would look at the IQ difference between me and my twin brother. And then what I'm assuming they do is kind of look at all the IQ differences in each of those groups. So they take all those twins that are DNA matches and same environments, and they look at all of those IQ differences and then maybe do an average. And then they could look at that average between the four groups. And using statistics, aka magic, they can then determine the heritability of some factor, in this case, intelligence. And this type of study has been done before for intelligence, and they've actually found a decently high heritability factor. For instance, in a meta-analysis done by Hayward et al. Of 11,000 twin pairs, it was found that the heritability of intelligence is around 70%. In other words, about 70% of your intelligence is due to your genes, and 30% is due to the environment you were raised in. And something that I read that's kind of interesting to me, and they talked a bit about this in the paper, in the meta-analysis, was that heritability of intelligence actually increases over time. So in this study that I was just talking about, the heritability for 12-year-olds was approximately 40%. So 40% of a 12-year-old's intelligence was due to their genes. The 70% that I just presented to you actually applies to young adults and adults. So in other words, when you're young, less of your intelligence is due to your genes. As you get older, more of your intelligence is due to your genes, which sounds kind of weird, but I think there's one theory that explains this where it makes a bit more sense to me. And this essentially says that at a young age, a person's environment is much more influential on that person's intelligence than in an older age. And this kind of makes sense, right? Take my twin brother and I as an example. If one of us was placed in a good learning environment at a young age, it's likely that our intelligence, our learning would kind of flourish and, you'd be a bit more intelligent at a younger age. However, the person in the bad environment would eventually catch up, as they went through school system, church, daycare, other institutions in the US. So let me just quickly summarize all of that. So through twin studies, we've been able to calculate the heritability of intelligence, which is around 70% for young adults and adults. However, it has been recognized that heritability actually increases with age, or I should say the heritability of intelligence increases with age. And so at an age of around 12, the heritability of intelligence is like 40%. Then as you get around 18, 19, 20, it kind of levels off right around 70. And also, though this may be anecdotal evidence, my twin brother's name is Ham. So Ham and I had high school GPAs that were like 0.02 points different. And we had ACT scores that were literally 1 point different. And then in college, we actually ended up studying the same thing. And you compare that to our siblings, and my siblings have ACT scores and GPAs kind of all over the place. So that goes to just support that there's a high heritability factor for intelligence. And of course, studies like these are limited by how one measures intelligence, right? If your measure of intelligence is not valid, i.e. it doesn't actually measure intelligence, then the results don't really mean shit, right? You're just measuring some variable that doesn't describe intelligence. And so, some critics will say that IQ tests or other intelligence tests don't really measure intelligence. They're measuring something else. They'll say that it's not a valid test. And so that's what I want to get into next, is how we measure intelligence. All right, so the last thing I'm going to talk about in this podcast is how we measure intelligence. And measuring intelligence is important, especially to psychologists, and it's also very controversial. And at the end of this segment, I'll kind of go over why intelligence tests are controversial and how they've been used in the past for not good things. But essentially, an intelligence test is trying to assign a person an overall intelligence score. Think about it as calculating Spearman's G factor. And typically this overall score is called an intelligence quotient, or an IQ. And IQs are calculated using IQ tests. And essentially an IQ or intelligence quotient test is actually a set of tests that are used to determine human intelligence. And the most commonly used set of tests that is able to calculate an IQ score is called the Welsher Scales of Intelligence. And this set of tests is broken down into 4 different categories. You have verbal comprehension, working memory, perceptual organization, and processing speed. And so what you do when you take a Welsher Scales of Intelligence test is you're given a series of tests, you get a score for each of these 4 categories, and those scores are used to then calculate your overall IQ score. Another set of tests that are commonly used to test IQ are called the Stanford Binet intelligence scales. And they actually break down this IQ test into 5 different categories, that being fluid reasoning, knowledge, quantitative reasoning, visual spatial processing, and working memory. And I wouldn't memorize any of this. This is just to show you kind of how these IQ tests are broken down, right? You're taking a series of tests that then are used to score your overall IQ. And in terms of the distribution of scores in a population, it'll just be a bell curve. So the mean will equal the mode, will equal the median, which will be a score of 100. And then as you go up into the tail and up into the leading edge of this bell curve, you'll get a very small percentage of people that are geniuses and have IQs of, 130 or 145. And you also have a very small percentage of people that have IQs in the 50 to 55 range at the tail of the bell curve. And according to free-iqtest.net, very legit, Charles Darwin had an IQ of 165, which is extremely, extremely high. That would put him in like the top 0.1% of people. He'd probably get early admittance into Mensa, but the IQ test, according to my research, was not invented until 1905, and he died in 1882. You do the math. And I did want to mention, too, that there's a difference between IQ tests and aptitude tests. So aptitude tests are designed to predict learning capacity for a particular area or a particular skill. So the MCAT, for instance, would be an aptitude test because it's designed to assess your potential for success in med school. Whether or not it does that, I don't know. But things like the SAT, the GRE, the ACT, those are all designed to test a specific skill set, which is your aptitude or natural ability for school. This is in contrast to an IQ test, which is designed to calculate like a single number for your overall intelligence. All right, so the last thing I want to talk about in this podcast is how IQ tests or intelligence tests can be somewhat problematic, and they've been used over the years for eugenics, racism, discrimination, and other bad things. So for example, IQ tests have been used to discriminate against different populations and different ethnicities. For example, according to Stephen Murdoch, who wrote the book IQ, A Smart History of a Failed Idea, talked about how the Nazis sterilized approximately 200,000 people based upon their IQ. And in Nazi Germany, this was actually legal. Like, it was in law that you could sterilize people based upon IQ. However, the Nazis also murdered hundreds of thousands based upon their IQ, and this was something that wasn't legal, so they don't have the exact numbers as to how many people were killed based on having a low IQ, but in Nazi Germany, people were killed because of it. Not only did something like this happen in Nazi Germany, the US actually had a eugenics program. For example, in North Carolina, there was a eugenics program that operated from 1933 to 1977, and this program said that anyone who had an IQ lower than 70 was grounds for getting sterilized. And the following is a quote from Wikipedia that says that the North Carolina Eugenics Board almost always approved proposals brought to them by local welfare boards. Of all states, only North Carolina gave social workers the power to designate people for sterilization, which is obviously a bit scary in the fact that it ran all the way up until 1977. That's something that I had no idea about. In addition to those two examples, many scientists over the years have measured IQ differences between different races. So for instance, in some studies, on average, it has been found that East Asian individuals score higher than white individuals, which score higher than black individuals. And this has been used over the years to justify racism. And of course, critics of this data point out that IQ tests might not be a valid measure of intelligence. They might not actually measure intelligence. And of course, others would point out that it's erroneous to link race to these differences in intelligence. It may be better explained by environmental factors, not necessarily hereditary ones. Anyways, I bring up these examples because I just want to show that IQ can be a very controversial topic, especially when you're talking about it in the context of race. All right, so that is it for the MCAT Basics podcast on intelligence. I really hope this helps while you're studying for the MCAT. I know, the test dates keep getting pushed back and back, and hopefully you're able to actually take the MCAT before the next application cycle if you plan to do so. As always, if you like this podcast, if you like what we do, go leave us a review on iTunes. It helps us reach more viewers, and I always like seeing the reviews.
Thanks for listening to Prospective Doctor's MCAT podcast. If you're a pre-med, you'll want to check out prospectivedoctor.com for tons of free tools, articles, and more podcasts that cover your pre-med life. And if you need help on the MCAT or getting into med school, check out medschoolcoach.com.